Hi, I'm Lou Brown from Spectradyne, and in today's video I'd like to take a quick look at how we might compare multiple data sets in the Spectradyne viewer software. So let's go have a look. Here you can see two lipid nanoparticle samples that were measured on the NCS1. You can see by these distributions that it's a very feature-rich data set showing subtle differences between the two samples. For instance, NP3 is showing us a mode of around 61 nanometers, whereas NP8 is showing us a mode around 74 nanometers. You can also see things like the green sample, NP8, has a much higher amount of large particles in the range above 100 nanometers. Compare this to what you would get from DLS for the same two samples, and you can see that DLS, or dynamic light scattering, only tells you that both samples have an average particle size of 66 nanometers. Certainly a lot less information. In this example, we've shown a dilution series with a single extracellular vesicle sample that's been diluted 10x, 20x, and 100x. In order to show the concentrations, I just simply typed in manual concentration select and then measured the concentrations, and you can see them displayed here. By eye, we can certainly see that this looks like how we would expect it, but let's do it a little bit more quantitatively. So to do that, I would simply go to data output, and I would output an integration range report, which would come up in Excel. It looks like this. All right, so we've got the concentration dilution factor, and then we can simply do a regression analysis in Excel, and you can see that we've got an R squared of 0.9994, which is pretty darn good, and exactly what we would expect from this type of dilution series. Another way I can show the exact same thing is simply to scale the graphs by their corresponding dilution factors. So let's go ahead and do that. So to do that, I go to my quantification tab, and I'm going to go down and I'm going to change the concentration by the dilution. So for the first one, it's 100x dilution, so I'm going to put that in. On the second one, it's a 20x dilution, so I'm going to apply that to just that one. And then finally, I'm going to apply a 10x dilution to the last one. And then when I replot these, you're going to see that they overlay just perfectly. So again, once the three runs have been corrected for dilution, they overlay perfectly on the graph, just as we would expect them to. This final example will demonstrate two things at once. First, we're going to show the repeatability of measurements in the NCS1, and then secondly, we're going to show you a very powerful technique for using in-measurement controls as a way of determining that the concentration is correct. First, this is an EV sample which has been measured in the NCS1, and you can see here that it's a power law distribution, which is what we usually expect. And so let's go ahead and measure the concentration over the full range of this cartridge. And we find that we've got a concentration of about 2.64 times 10 to the 8th particles per ml. But how do I know, and how can I prove to myself that this is the right absolute concentration? And that's where this technique of spiking in control beads to the same sample comes in very handy. This is something you can't do with other techniques. So I'm going to go into multi-mode now and replot this CSD. And now you can see both runs. The blue is the original run without control beads. The green is the second run with the control beads in it. And first of all, you'll see that the two samples agree very well in the EVs here, and the only difference is this spiked in 208 nanometer control beads. When I mix these beads before I put them into the sample, I mix them at 2 times 10 to the 8th particles per ml. So let's go and measure them and see how well we did. So I'm going to just measure the area here where the beads are. And if I click on concentration and bring that up, you'll see that in fact I got 2.1 times 10 to the 8th particles per ml for the spiked in beads, which is exactly how it was mixed, and thereby proves that the concentration measurements I'm getting from this measurement are exact. So this has been a quick look at how you can look at multiple data sets in the NCS1 viewer software. I hope it's been informative for you, and we invite you to keep tuned to our website as we keep adding more videos showing more details about the NCS1 and nanoparticle analysis in general. Thank you.